Hey, hi guys, welcome back to the channel. So, we are working on our audio processing series. So, if you are new to the channel, make sure to subscribe to our channel and press the bell icon and like the video as well. So, in this particular series, we have already covered first 5 topics where we see how to load an audio file in Python, how to visualize audio in Python, how to remove noise from an audio, how to remove silence from an audio, and how we can extract MFCC features from an audio. This part we covered in the last video. This video is gonna be a continuation of the last video. In this particular video, we're gonna see how we can store the MFCC features and how we can compare MFCC features from two audio samples. So without wasting any time, let's get started. So if you have seen this particular code in last video, if you are not seen this particular video, then just go back to the our playlist and check out the video. In this particular video, uh, I will just delete these things. Okay, so in this particular video, we're gonna see, first thing is we're gonna see how we can save the MFCC features. So in last video, we you can see we have extracted the MFCC features and we saved the MFCC features into this particular variable, which is combine MFCC features, right? So now what we're gonna do, we're gonna create a variable and we're gonna save these particular features. So now we are assuming this particular combined MFCC features is our feature matrix. So if this is our feature matrix, we can save this feature matrix with the help of NumPy library. We have already imported NumPy library, so we're gonna use NumPy library and we're gonna save this particular combined MFCC features into .npy file. I will show you how we can do that. So we're gonna use save function from NumPy library. We are specifying the name of the file. This is gonna be our saved file, and we are passing this MFCC feature matrix. So what this function gonna do? It will save all those features in one MFCC file. Let's execute this code. So here you can see we have successfully saved our MFCC features file. I will just refresh this thing. You can see our file is generated. Now with the help of this file, we can compare whether this MFCC features belong to the same person or different person. What I will do, I will just execute this particular code one more time. I will just change the value here. So earlier we saved the same MFCC features into MFCC features npy file. I will just execute this code one more time. So now you will see one more file here. For both the files, the MFCC features are same. So our final aim will be, when we compare these two MFCC features, there shouldn't be any difference in that. So let's see how we can do that. For this particular thing, we need scipy library. Okay, so from scipy we will import Euclidean function. Often in machine learning algorithms we usually use Euclidean distance. We are using the same here to measure the distance between two particular audio samples. Okay, so let's load those two samples here. I will just load them first for with the help of numpy.load function. There are two different files. One is features.npy and features1.npy. Let's just load these particular files. Once we load this file, we will use the Euclidean function, and with the help of Euclidean function we can measure the distance between this particular two audio samples. So we have successfully calculated the difference. So let's check whether these two audio samples are of same person or not. So for that, first we will define one threshold. Threshold nothing with the similarity percentage. Right now I am keeping the similarity percentage as 50%. 0.5 means 50%. So now let's check whether these two audio samples are of same user or not. So what it will do, it will check whether our distance, this particular distance, is less than the threshold or not. It should be less than 50%. So deviation between these two audio samples should be less than 50%. If it is less than 50%, we will see this particular both the audio samples are of same person. So let's execute. That's what it's saying. So it is saying audio samples are likely to be from the same person, because we have extracted all these features from the same file. That's why it is saying these are likely to be same person. Let's print the distance. Let's see how much difference is there. It should be 0. If it is 0, we can say our code is working fine. So this is how we can extract the MFCC features from an audio. This is how we can save the MFCC features, and with the help of Euclidean formula we can extract the distance between two different audio samples, and based on that distance we can check whether these particular samples are of same person or not. So here we're gonna end our audio processing series. We covered all these 6 points in this particular series. If you have any doubt, just comment in the comment section. I will reply back to your comment. And if you want code for all these videos, please comment in this video. I will share a zip file with you. So this is gonna end this particular series, but what I will do, I will create one more long video where I gonna combine all these points, and we will create a simple voice recognition system with the help of normal Python libraries. So if you want that particular video, make sure to subscribe to our channel and press the bell icon, so that when I will upload that particular video, you will get the notification. So that's all for this particular series, audio processing series. If you are new to the channel, please watch all these videos, gain understanding. If you have any doubt, please ask me in the comment section. That is all for the series. We'll meet in next series. Thank you for watching. Bye.